So in the last class we were learning about project evaluation and review technique or PERT. Okay, so for the basics we used to express two events as circles and arrow as activity, same as CPM, and we had three time values instead of a single time value. They were optimistic time, pessimistic time and mean time. Okay, so using these three time values we will calculate TE or expected mean time as a singular time value. TE, the equation was T0 plus 4Tm plus Tp divided by 6, and standard deviation sigma T was found out by Tp minus TO, pessimistic time, minus optimistic time divided by 6, and variance as always will be found out by squaring standard deviation. Tp minus TO whole square divided by 6 square, 36. Okay, today with this basics we are going to learn about probability of completion time. Probability of completion time of any project. The idea is, if you suppose you have a project and its critical path duration is 15 weeks. So you will have a network. It can be small or large. For any project, there is a network diagram. And suppose the critical path duration, the duration of critical path, that will be the biggest path, right? So critical path duration of that project, of our concerned project, is suppose say 15 weeks. Okay, so 15 weeks is the critical path duration, and we want to know whether how much is the probability, chances of completing it within 14 weeks. Okay, and we also want to know how much is its probability of completing with 17 weeks or 16 weeks. Okay, so we want to find out how much is the probability of completion time of a project. Okay, I think it's clear right now. So we will be having a critical path duration, and using that critical path, with respect to that critical path duration, you want to know how much is the probability of variation. There can be positive variation. For example, we are considering critical path duration 15 weeks, and 16 weeks if you are considering scheduled, we want to know probability of, that is positive variation. If you want to know of 14 or 13 weeks, it is negative variation. It can be both sides. Okay, so we just want to know probability. What is the chance? What are the chances of completing it at this much duration, or what are the chances of completing it at this much lesser duration? Okay, so for that we will be taking help from an external table. We will let you know at the time. So probability of completion, for this we have step 1, calculate standard deviation of critical path. That is, you have a network diagram and you have a found out critical path, and using this critical path you need to calculate standard deviation. So for example, you will be calculating this with respect to root of sum of variances of activities in critical path. That will be, so as you know, variance is the square of standard deviation. So what we will do is, we will calculate each variance of each activity along the critical path only. Okay, it will be more clear when you do an example. So along each activity we will calculate variances and sum it up for each activities and we will take square root. That will be standard deviation of critical path. Okay, so that is sigma. Step 2, calculate Z. Z is, we have an equation, Ts minus Te divided by this calculated standard deviation. Okay, where Ts is scheduled duration. Scheduled duration means, in our previous example we want to know the probability of completion of that project. We suppose the time period was 17 weeks or 16 weeks. Okay, so the critical path normal duration was 15 weeks. We want to know the probability of completion of 17 weeks. That 17 weeks is Ts. 17 weeks. Our original critical path duration, that is expected duration, that is 15 weeks as per our example. As per critical path. Okay, so Ts, T, sigma you already know, this is standard deviation through critical path. Okay, so you have Z, and last step, find probability with respect to Z from standard normal distribution. Table. Okay, so here comes the normal distribution table. And using this normal distribution table, you can take out probability with respect to Z value. That's it. These are the 3 steps. You have to calculate sigma of critical path, then calculate Z using Tz minus Te minus divided by sigma, where Ts is scheduled duration and Te is expected duration, and you just corresponding, you just take the probability value. It will be a decimal value, less than 1 obviously. Probability value from this table that will be given to you already. You don't have to memorize any of those things. You just take out the probability value corresponding to this Z value. Okay, for an example, if Z is equal to 0, probability is 15% or 0.5. That is, if T was 15%, 15 weeks, right? And suppose we are substituting Ts as 15 weeks itself for the critical path duration itself. Ts 15 minus T 15, that means 0. You are not altering the critical path duration, then that probability will be 50%. Okay, so it actually goes like this. This being Z is equal to 0. Okay, so this is the 3 steps that should be following for calculation of probability of completion time. Okay, so we will get into an example and that will be clear. Okay. So this is the question. So we will start drawing the network diagram right away. So 1 to 2, 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6, and finally 5 to 6. Okay, so you didn't get this neatly, just draw one time more neatly. Okay, so you have three time parameters: optimistic, mean time, and pessimistic time. So using the equation T is equal to TO plus 4TM plus TP divided by 6, calculate T values. Okay, the values are 2, 4, 3, 1, 6, 5, 7. Okay, so you have TE values, expected mean times of each activities. Okay, so then what you need to do is just calculate sigma square, that is variance of each activities. That is very easy, as we know. Sigma square is equal to TP minus T0 whole square divided by 36. So for each activity substitute TP T0 and square it and divide by 36, and the values are 1 1 1 0 4 1 4. Okay, so we have TE and sigma square values. We calculated sigma square because we need to find sum of critical path activities variances as step 1. Okay, so step 1, sigma square ij of critical path values. So you need to find out which one is the critical path, right? So for that we can just calculate from TE values which one is the critical path. Okay, so we have three paths from which it can be started and finished. One is 1 3 5 6, 1 1 2 5 6, 1 2 5 6. Second one is 1 3 5 6, 1 3 5 6, and the last one 1 4 6. Three parts, only 3 parts. Okay, so one of these 3 parts is critical path. How do you find it out? Just add all TE values of corresponding activities and find out which one is the biggest, the longest critical duration path will be the critical path. As simple as that. You just calculate, that is calculate sigma T. Sigma T is 1 2 T is 2 2 5 plus 1 5 6 is 7, that is 10 minutes. And 1 3 4 plus 3 5 6 and 5 6 7, that is 17, and 1 4 is 3, 4 6 is 5, that is 8. As you know, 17 is the biggest value, hence 1 3 5 6 is critical path. This is the prioritized path. So we denote critical path by these 3 lines, and as we know, 1 3 3 5 and 5 6, these 3 are the activities concerned with critical paths. Okay, so step 1, that is equal to sum of variance values, that is 1 plus 4 plus 4 whole root, that is 9, that is equal to 3, that is sigma, standard deviation. So step 2, z is equal to Ts minus Te divided by sigma. You have just found out 3 as sigma. Ts is the scheduled time duration and Te is the critical path time duration, that is 70. Okay, so in any of these cases Te will not be changed from 70. Ts will be changing with each case. So first case, find probability of not completing in 18 weeks. Okay, so you want the probability of not completing the project in 18 weeks. So instead of, we start with probability of completing in 18 weeks. Right. Okay, so we start with probability. We are calculating probability of completion in 18 weeks, that is Z is equal to Ts minus Te by sigma, that is equal to Ts is 18 minus T is 70, sigma is 3, that is 1 by 3. 1 by 3 is Z value, and from this Z value you calculate so corresponding probability is 63%. So we have 63% probability for completing at 18 weeks. Okay, so what is probability of not completing 18 weeks? That is not completing probability 100 minus 63%, that is 37%. Okay, so as you all know, 1 is the complete figure. The occurring of probability of occurring of an event will be a fraction, and not occurring of an event will be the remaining from 1 or 100%. So probability of completion 18 weeks is 63%, and probability of completion of not completion in 18 weeks is 100 minus 60, that is 36. I think it's simple enough. And last question, 3 weeks earlier. Right. So Z is equal to Ts minus Te divided by sigma. Ts is, as Te is 17, Ts will be 40, that is 17 minus 3, that is divided by 3 minus 1. Okay. And that will be probability %15.9%. There won't be any negative values for probability, as you all know. So 15.9% will be the probability of completion of this project within 14 weeks. Okay, 3 weeks earlier. So that's it. I hope you have these 3 steps, and step 3 was refer normal distribution table. That's it. Okay, so please try out more problems. Thank you.